Good morning, everyone. Welcome to another episode of Xa Talk Show. Today's topic is no topic, random. So you ask questions and I answer. Okay? So ask question now. Okay, so no topic. So I'm just gonna start to do random and 100 milliliters of red wine to soothe my soul, soothe my brain. Today is 2023, October 11th, and we are currently in the troublesome world. There's a big killing going on, the politics, huge killings. Hello, Chinese people. 什么什么什么 what the fuck is your name? That idiotic Chinese characters. Some people love to use that idiotic, super complex Chinese characters. Actually, I can explain that. Immortality, good morning, or good afternoon, good afternoon, or good midnight, or good evening. Intex 080, Daniel, good night, and God's Son. Oh, God's Son, cheers, cheers. So no topic, so ask a topic, okay? Ask a topic and I'll talk about it. So here's my keyboard, glove 80, search xali.info. I have a video review, fantastic. This one is Ultimate Hacking Keyboard, version 2, also fantastic, okay? Okay, let's switch to my desktop so you can see what we're gonna talk about, random stuff. Okay, Andrew, good morning, Andrew from Midwest. What do you mean by super complex Chinese characters? Okay, you see the person above you, Andrew, in the comment. Let me copy his, so you can see, let me copy his name. Copy, okay, now back to Emacs. Now you can see, open a new window, okay, there it is. Now magnify, okay, so this is Justine. Hello, Justine, the mathematician from Canada, the professor from Canada. Is that you? I think so. Long time no see. Justine love this kind of shit. Well, I have more to say, but maybe I shouldn't. But anyway, Justine, long time no see. How are you? So, what do you mean by complex Chinese characters? So like these, okay? So these are Chinese characters. I mean, they are rarely used. They are never used. Like in English, sometimes you see, for fun, people wants to find what's the longest word in English. Okay, so let me show you. Okay, so it's similar in Chinese, analogous. So what's the longest English word? Okay, now the power of my Emacs to search for that. You see, what is the longest word in English? So here are a few huge monsters. Let's see. Okay. So God, this fucking idiotic fuck Pajit site. But anyway, let's see the longest word. Okay, blah 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 blah. Okay. So pneumono ultra microscopic covocanaconiasis. Okay, that's supposed to be the longest word. It used to be some kind of communism stuff, okay? 15 longest word in English. The fucking idiotic, irrelevant pictures. You see these scam commercial websites. Okay, God's question. God's Son's got a question. I had a random question I was curious about. Theoretically speaking, could you build a C language in Lisp? No. As in write C inside of Lisp. Yes. I know a weird question, but was curious. Okay. So what kind of question is that? So you want to, so could you build a C language in Lisp as in write C inside of Lisp? Yeah, of course you can. That is actually, I don't think that's too difficult. All you have to do is just make, I mean, to do that, you basically are writing another language because Lisp does not support, syntax like C. Lisp has reader macros, which facilitate for you creating different kind of syntax, but still Lispy, still lots of nested parentheses. So Lisp, by the fundamental nature of Lisp, it does not do, the C syntax. Of course, you can add it, but if you add it, it's no longer Lisp. You are just doing your thing. You are just creating a new language with part of it, Lisp, part of C language. Okay, so so that's okay. So I'm jumping around. I shouldn't jump around. Let's go back to this. Let's finish one topic at a time. This Chinese character and what's the longest word. Okay, so the longest English word I know, it used to be like 10 years ago, involves some kind of communism concept. For example, antidisestablishmentarianism. Okay, that was the longest word I know. And yeah, so in Chinese, you have kind of a similar thing. Chinese words are made of characters. So you have this character, this like never used, just like the longest English word. It's never used. You don't even know what it means. So this word is made of 3 characters of the word for thunder. Okay, so let me type the word thunder for you. Okay, in Emacs, we can do it in Emacs or we can do it in Windows. Let's do it in Windows first. Okay, so Windows Notepad, yeah, okay, Notepad, but Notepad is gonna be, okay, so now you need to switch to Chinese. Now I'm gonna type the word thunder. Oh, in Chinese. Okay, this character, LEI, okay, LEI number 3, yeah, okay, and then magnify. Okay, this is the Chinese character for thunder, thunder. Okay, then so you can see this character, which this Mr. Yang, professor mathematician from Canada, he put in his name. This character is made of 3 thunders. Okay, what does it mean? Yeah, I'm not sure. It's like something related. Okay, so let's look up what does that mean. 3 thunder character in one. It's just for shit laughs. Nobody uses this word. Okay, so let's see. Wiktionary. Let's magnify. Okay, Chinese source Asian Chinese Speak Dictionary 康熙字典大汉和字典汉语大字典 page number 1381 something and 16th character. Okay, so but what does it mean? Like, show me where is the meaning of this. 仅用于雷雷. Okay, so this character, so this character is pronounced Bing. Okay, it's like Microsoft Bing. So this character, 3 thunder characters, is pronounced Bing in Chinese, in Mandarin. Okay, and the only use of this word is in the combination Bing Bing. Okay, so let's see what is the Bing Bing. Okay, it's pronounced bong bong here. Bong bong bong. Okay, so I suppose it just means thunder, like bam bam. So where's the meaning? Yeah, okay, so the sound of thunder. So the Justin Professor Yang Pu, you are an idiot. He loves that. This thing. So, and the second character is made of 3 characters for dragon, okay? So let's type the dragon. In Chinese, it's long, okay, Long, okay? So the first one is simplified character for long used in China, but let's get the traditional character for long, okay? This one, fuck. Let's try again. Second page, number 4, okay? So these 2 characters are the same. The first one is simplified long, okay? The second one is the traditional. It means dragon. The concept of dragon is different from Bing Bing. Okay, so anyway, the concept of dragon is in China is different from Western dragons. Okay, Western dragons is typically evil. It looks like a dinosaur. It got bat wings and it can breathe fire. That's a Western dragon. But let me show you a Chinese dragon. Okay, you probably have seen it in Chinese New Year festivals and stuff. But the Chinese dragon is typically good omen. So Chinese dragon is kind of like snake, but with eagle claws, and it's got this, so that anyway, that's Chinese dragon, okay? Okay, let's switch back to English, okay? Chinese dragon. Okay, so you got this, many pictures of Chinese dragon. So Chinese dragon is not evil, typically like evil thing. And it's also typically it's good thing. It represents the king, the emperor usually. Good omens typically. So here you have a Chinese character made out of 3 dragons, okay? Now let's look up Wikipedia. What the fuck that is? Okay, so this is Wikipedia. So it says, let's see, da. So it's pronounced da. So what does it mean? So so okay, so it means flying dragon. Okay, I mean it means it describes when dragon is flying. So you have 3 dragons, and also there's another character that's made out of 2 dragons, which means exactly the same. So anyway, that's a funny thing. Hello, George. Traditional looks better. Yeah, it does, but that's debatable, okay? So, in fact, I have an article on that. So you go to, let me show you, okay? xali.org. So this is my website. And you go to Wordy English, okay? And I have a Chinese blog. So you go to Chinese blog. Oh, speaking of dragon, I have an article on dragon. This quote, the nature of a dragon. This, well, if you don't speak Chinese, then I cannot explain. It's it's very interesting. Okay, but anyway, so we're talking about we are talking about the simplified characters. So let's go to that part. 莎莎中文笔记. Okay, Yang Pu Justin says second tone. So what does this? So this word is pronounced da da. Okay, da. I guess second tone. Da 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 da. No, according to Wikipedia. Da. Da or, so they have two pronunciations, da or da. Yeah, idiotic big five. Anyway, so so that's the thing about that. So anyway, about simplified and Chinese simplified character. So you can go to my, for example, I have a list here, a list of simplified and traditional Chinese characters. So this is actually a complete list, okay? The blue one is simplified, the black one is traditional, and the red squared means they are simplified from Asian characters. So for example, we were talking about the character thunder, and here is a character for lightning, okay? So the traditional character is like that, okay? It's very similar to thunder, okay? But however, the simplified is like that. So the simplified is actually from Asian. So 1,000, 2,000 years ago, the character lightning is written in the simplified form, okay? So in that sense, the simplified is actually better. But actually a lot of the simplification, they got screwed up. Anyway, and then I have an article. I have an article about which one, good or bad Chinese simplified characters. So here it's my notes about which characters simplification is better or worse. For example, all these are good simplification. By the way, my Chinese name is Li Sa, 杀人的杀, okay? It means kill, 杀力. Sa means kill, okay? So in traditional form, that character is written this way. But you see, but the simplified form goes back to the way it was written 1,000 or 2,000 years ago. So you can see this character, kill, is like off with your head, okay? So this character, it makes it simpler, you can easily see, okay? So that's why I say, for example, this word, the simplified form is much better. And you can see this character means air or qi, air or kind of spirit. So it's also simpler because it's like a cloud, it's air, and this character means the cloud. Okay, so this one is also simpler. It makes more sense, cloud, and this word is tears. Okay, your tears. So this one is also simpler because on the left side you have water, on the right side you have eye. So water in the eye, tears. And the traditional form got fucked up. It got the dog inside the house. So if you want to judge about simplified versus traditional, you can, it's lots of study and useless basically. But there's a lot to go through, thousands of characters. Okay, that's about that. So let's go back to some English topics so all the English people, non-Chinese, can appreciate. So I talked for 20 minutes. Any other questions we have? Yeah, so let me read the questions. So, why did you start wearing a Maoist hat? Well, because it's not that I really, decided to have this hat. It's just by chance I got this hat. And this hat, you see, now I cut my hair. My wife cut it for me. So I think I look better with the hat now. Let's see which way do I go. Oh, I'm going to go here, here, here. Okay? Now I'm a red guard. I defend justice. Godson, Hexa. So the Lisp question I kind of answered. You have to kind of study compilers and to really know that. Mary Poppins. Int 80 says int x080. What does that mean? So let's look up. So this guy, our friend, his name is int 0x80. Now typically the 0x something is the C language's idiocy to represent a number by hexadecimal. The C extreme idiotic fuck. Okay, C language. Okay, so what is the hexadecimal 80? I don't know. So let's see. Can we find out? Yeah. Let's see. Let's use multiple technology to find out what is the hexadecimal 80. Okay. Let's do emacs lisp. Okay. So let's do emacs lisp. What? Okay, let's do emacs lisp. Let's do JavaScript. Let's demo the power of my language knowledge. Let's demo Wolfram language. So we want to know what is the hexadecimal 80. So in other words, convert hexadecimal to decimal. Okay. Well, so in Emacs you represent. In Emacs Lisp you represent. Yeah, if you want to input a hexadecimal, all you have to do is this with this syntax x80. Okay. So that's that. So do it. So see, it's 128. Oh, 128. That's the, that's the powers of 2. Oh, that's 8 bits. Wait, that's 7 bits. Where do you use int 80? Where do you want 7 bits? 7-bit ASCII. Anyway, so this is Emacs Lisp. Okay. How can you convert a hexadecimal to decimal? Now JavaScript, JavaScript, the idiocy. Oh god, JavaScript. Okay, JavaScript is parseInt. Okay, let's go to XAR JavaScript mod. Now let's show some my pink window so you can see XAR JavaScript mod and parseInt. Yeah, parseInt. So number and base. In fact, does JavaScript support input of hexadecimals? Okay, red wine gun. JavaScript input of hexadecimals. Does it? Maybe so. I don't remember. But let's use the int. Okay, so 80 parseInt. So base 16. So console log that, run it. Buffer is not a file. Save it first. Okay, let's run it in your browser. So Control I, Shift Control I. So we get the JavaScript console log and paste it there. So can we magnify here? Yes, kind of. Enter. 128. You can see. Fantastic. Now, does JavaScript support like 0x80, the C dot notation? It does. The fucking idiotic C fuck. It's a, C is a virus. It's a cancer. So this idiotic, idiosyncratic notation spread to every language. The C fuck and Unix. Okay, let me tell you. So okay, so let's copy that. let's copy that. So JavaScript is that, okay? And or it's just that, okay? Now Wolfram language. Now let me show you Wolfram language, why it is super powerful. Now typically in the C industrial programming idiots, C, Java, Python, Ruby, Bash, C++, Rust, these idiots, in their head, because of C, because C began it and it spread and it brainwashed all of them. In this idiot's brain, they don't have a concept. When they see, binary or hexadecimal or sometimes octal notation, they don't have the concept of, let's say, base 9. If you tell them, if you ask them, can you show me, okay, wait, start Mathematica, okay, start a Wolfram language, we're gonna show later, okay. First of all, let's say enter 3, okay, 3 plus 3, okay. So in these people, they only know binary, octal. Sometimes octal is like forgotten these days, and hexadecimal, right? But if you ask them, can you show me a number base? Let's say what's 100 in base 9, and they'll go what? Fucking C idiots and Unix, fuck. So the number base is a general idea, but if you came from mathematics, came from mathematics, a mathematician, then you understand the concept of number base, not just binary 2, 8, 16, fucking binary, fuck. You understand number base in a general sense. So for example, do we have number base? Okay, so let's see what is the function in Wolfram language for what is this? Oh, that's so we want we don't want, those are chapters. This is section heading, okay. This is some kind of section heading like orgmod, so you have, for example, if you press Alt 1, this is, you got the title. Alt 2, you got section. Then you can have Alt 3, subsection, so on. That's why you are seeing this bullet thing. So anyway, what I want to type is actually asterisk. Type it wrong. So Shift 8. Why is Shift A become that? Okay, Shift 8. What's going on? Is my keyboard screwed? What? Okay, now you got so I want asterisk. Oh yeah, I want base. So I want to see what functions are available for the number base, okay. Base decode, base encode, base form. Okay, let's see what is base form. Okay, so there it is, base form. Base form, okay, and you can, so let's say 80, then what base? 16, okay. Wait, base form expression n prints the number in expression given in base n. So why is this? What? So let's look up the documentation. So Yeah, so why is this? Oh yeah, so that's right. Oh yeah, so that's right. So what you want to do is you want base 128 in base 16. That's 80, okay? But we want to do the reverse. We want to know what is 128 in base 16 in decimal, okay? So base form, what's the other function? Actually, Wolfram language also does the, I think I'm pretty sure it also does the, does it? No, it doesn't. So number form, okay? Number form is the thing you want. Okay, number form expression n prints with approximate real number of expression given to n digit precision. Okay, and with, wait, that's number form is not it. Yeah, okay. You have a special notation here, okay? So you want to say 80 that 16 failed what? You can enter number in any arbitrary base using, oh, okay, so that's, so instead of you base 16 80, okay? So that's how you do it. Took all the trouble. WolframLang is like that, okay? So there it is. So what is the other questions? Let's see. Oliver, $5. Thank you. Oh God. All this talk got wasted. Shit. Yeah. So okay, so yeah, wasted 10 minutes. Okay. So anyway, in Emacs Lisp is just that. Okay. In JavaScript, it supports the C. Okay. That's the reason is because I have one too many drinks maybe. So in JavaScript is that, okay, the, you know, you can do it direct input, you know, base hexadecimal, or you can convert, you know, from a string hexadecimal base 16. In Wolfram language, it's just this notation, okay? So by the way, so this notation, so why Wolfram language has this notation? Because this notation allows you to give it in any base. So for example, let's say base 2. Digit at position 1 to 80 is too large. What? Oh yeah, so there's no 80 in base 2. So okay, so let's say base 8. Base 8 you have 0 to 7. You don't have 8. So okay, so anyway, base 3, okay? Wait, you gotta have some, let's say base 9. So the number, the base 9 notation of A0 in base 9, that is decimal 92. So the point about the Wolfram language notation, this, you know, with the base and correct and the number, allows you to input any number in any base, okay? Get that? Any number in any base. So let's say 800, 8,000 or whatever. Let's say base 17. Let's say base 17, okay? What is that in decimal? And okay, in decimal, that's 11, 358, 856, okay? This is how in Wolfram language you input a number in any base, okay? So previously I was talking about, previously I was talking about how C language, this C language, a virus syntax spread to all the languages, this 0x. So why does it suck? So let me describe why I hate C. This is a prototypical example of the C idiocy to the extreme. C and Unix fucks. Okay, this is the cream of the example of C. I don't hate C because it's low level, because it's assembly, because it's not mathematics. No, that's not the reason. I despise C and C++ and the whole bag of industrial programmers with their binary operators fuck. Because they don't have a brain. They design their language in a way it's all hack. Okay, this input, this is called literal expression for number. Okay, technically. So this number input is one of the best example. You see, so you want people to be able to input a number in any base. Okay, so the C people came up with this. So you start with a 0, then you start with x, yx. No particular reason. It just it's just convenient. So what if you have 0a 80? What does that mean? Well, it doesn't mean anything. So when you have x, that's special. It's a special syntax, special, okay? It's an exception. So you have to, everything in C, you have to remember, this is for this is, this little thing, fuck C. Then, so x, yx, x stand for hexadecimal. So you can have 0x, so this is, the input for hexadecimal. So if you want octal, then it's 0, I think I forgot, but if you want binary, it's is that right? So I don't remember it's right or not. So can we do that? Let's say 1100. Okay, let's see JavaScript browser. Okay, so this is, we were using the browser console before. Yeah, it does. So this is a C invention. So you have like B for binary. What about O? So I think that also works. Okay, no, octal is not that. But anyway, you start with 0 and B, that stand for binary number input. 0x is hexadecimal. Okay, that's C language kind of created this whole thing, and it spread to every language, and it brainwashed the industrial programmers. So why do I despise this? Because you see, they use X special, it's just special. It's like, it's just irregularity, filled with irregularity, X and B. Okay, so what about if I want a number in base 9? Oh, you cannot do it. What if I want a number in base 3? You cannot do it. And what does it mean if you have, 0A or 0C? Oh, that doesn't mean anything. It's just that special case, this fuck C and Unix. This is the reason I despise C and Unix. And when you talk to the C people, they don't understand, this. We have a few on our forum, basically the whole industrial programmers, they don't get it. They don't understand. Then they'll say, oh, why do you need base 3? Oh, you don't need it, So anyway, the characteristics of this problem is that it's just a hack. That's what C and Unix do. It's just hack. It works. It works. Everything, syntax, everything about every decision in the programming language is like that. Why do you? Okay, so let me answer the question. Why do you need base 9? You see, the number base is a general concept in numbers. Okay, it's about the notion of number representation. So it's a general concept. So what is the so it's a general concept. So if you design a language, you should be able to you should be able to represent all these spaces. And why is it useful? Because different number bases have many different uses in mathematics, just in general. Now, the binary happens to be extremely useful because that's one of the end of a spectrum. You have base 2 starting with 2. You cannot have base 1. So 2. So that's the kind of the simplest, and it happens to be extremely useful for computers. Then, so why is hexadecimal base useful? Well, because it's a factor of the binary. It's power of binary, so you can condense the representation of a number. That's why hexadecimal is frequently used. For example, in CSS, in the fucking CSS color, which also began by Unix, which fucked up the entire industry. You represent the color by okay, so let me show you. So let's see if I can find it. So we want to find A. Let's see if we can. Yeah, there it is. You see, FF0000. That represents red. It's like cryptic fuck, and it becomes standard everywhere. That's not the way. In Wolfram language, if you want to represent red, you can actually just say red. Okay. But if you want the general spec, you can say H. Fuck. So I want this. Now this is wrong. Shift star gives you that. That's not good. Yeah, I don't know why is Wolfram is doing this. But anyway, so I want color, okay. So you want, it supports CMYK color and lots of color representations, okay. So okay, I'm kind of going nowhere here. Yeah, so the color is represented by the keyword hue, okay? Yeah, I remembered. So hue, so you can hue, 0 is red, okay? What about, so you can give more options. Let's say 0.5 is the saturation. Okay, so, but what is hue exactly? Let's look up the documentation. Okay, so here is the documentation for hue. So hue is HSB model, okay, means hue, saturation, brightness. Okay, and Wolfram also supports several other, you can specify RGB color. So let me show the design issue, okay? So for example, RGB, like the Unix fuck, okay? The Unix, which is a virus, the Unix and C design is a virus. It's spread and spread and spread to all, so that the typical, for example, average programmer or CSS designer today, when you ask them what's a color representation, they'll just say this, okay? They'll just say this, nothing else. Why? Why do we represent, with this cryptic FF, whatever B, fuck? Because C and Unix idiots. Okay, so that's why computer language today, when you code web or whatever, it becomes extremely complex, filled with baggage, because these people don't know anything about design. All they know is that back in 40, 50 years ago, this is the simplest, it just works. Use less memory. That's these idiots. So anyway, so this color short syntax is RGB. So of course I have 1,000 articles on that. So if you just search for XAR CSS tutorial, you can see visual CSS, okay? So here is various ways to represent color. traditionally it's represented by three hexadecimals. Each one is 2 digits. Okay, so you can choose color wheel. You see, and then you can represent by, so here's the basic colors by this hexadecimal fact. Then you can represent, then CSS, then CSS, stupid CSS, they created shortcuts. But anyway, then in 10 years ago they created more different syntax, so you can now, so instead of hexadecimal, incomprehensible fuck, now they finally, after 10 years, they created this RGB. But however, they also got it wrong. It's from 0 to 255. A fucking idiocy. This isn't, you see, I'm concerned about it because it's a bad design. It's brainless design. Why 255? Why is the maximum 255? Who the fuck told you that? C and Unix idiots. Okay, so anyway, so let me show you Wolfram. Okay, so RGB. Okay, RGB color. You can also actually choose. So here is Wolfram language. So this syntax RGB color is analogous to the CSS this syntax. Okay, now the difference is that in the CSS syntax you have to use a number from 0 to 255. That's the range. In Wolfram it's 0 to 1. Okay, this is the best, most beautiful design, because 0 to 1, that's a real number. That's a range of real number. You can have infinite precision. Whenever technology improves 10 years after today, 100 years after today, it still works and still best design. But the 255 is a fucking idiocy. It's just a special thing. You got the magic number 255. That's a Unix, and also they start with 0. The most idiotic fuck from the C and Unix brainers. It should start with 1. 1 to 256. Okay, 1 to the 2 to the 8th power, 256, 6. Not starting with 0. Starting with 0 got lots of problems. Okay, that's lots of rant. That's it for today, maybe. Okay, so I talked for 15 minutes. Why would you want base 9? Okay, so so did I answer the question? Well, let me give you let me give some credit to the C design. Okay, so you see, so base 9, so in programming, the most useful and practical number base is 2 and 8 and 16. Okay, it happens to be useful, well, because base 2 is what computers use, because electricity on and off represented by binary 0, 1. Okay, then you have octal or hexadecimal. That's only because they condense the base 2 notation, so you don't need so many digits. It's mostly used for programmers to read. Okay, so that's why octal and hexadecimal are used. Basically no other reason. Just because the only reason is that they are short representation of binary digits. Okay, and binary is needed because computers are binary. Okay, so why is base 9 or other useful? Well, that's just general mathematics. Okay, so in computers they are not that much used actually. So there is, I have been dramatic. I was, dissing C. So I mean, in practice, you only need base 2 in computing. At least you just need base 2, base 16. So that's why the C fuckheads created this idiosyncrasy. And so why don't we, why didn't they, go with the Wolfram design so that you can have any base? Well, because they don't, back 40, 50 years ago, if you go with the Wolfram design, then you have to write a generalized algorithm to take, you know, any base, to convert any base. But you don't need it most of the time. So they just go with the shortest, speedy, you know, the hack possible. That's C. That's the life of C. That's the story of C and Unix design. And it's practical, you know. So one of the why is C everywhere? Well, that's because they are the most practical. They are brainless, but they just go for the most common needed thing, you know. So that's why. Well, yeah, George has that argument. Starting with 0 makes sense for RGB. Well, yeah, in some cases, but not in general. I mean, that gets us into the discussion of array indexing and all that. Well, I mean, well, so for color, so you are saying starting with 0 makes sense. Not really. You know, you see, I don't, you know, no, that's false. Okay, so let me explain why. God, what's this special character? So, you see, when you, so let me show you. So, okay, so let's talk about the color representation. For example, this Wolfram syntax. So let's say we are using the RGB model, red, green, blue. Okay, there are many other models, hue, brightness, saturation, you know, and so on. But RGB is one of the popular model. Okay, so in this model you need 3 numbers, right? So in the Wolfram language, in a Wolfram function, each number has a range of 0 to 1. 0 represents the minimum amount, 1 is the maximum. Okay, 0 to 1, the best design. Okay, so but in typical Unix and C and, you know, and then in CSS, it's 0 to 255. Okay, why 255 in particular? Well, that's because basically you have 256 values, 2 to the 8th power, binary, again involving binary. Why 256? Well, that's because you have 8 bits, you know, represent, you know, the physical device, 8 bits. So anyway, 256 possible increments, okay, from 0 to 256. Not as opposed to the Wolfram language, infinite, 0 to 1, infinite. You know, if you study real numbers, you know, that's infinite amount of precision, okay? But anyway, in C, in you know, in CSS and C, we have 256. But however, they start with 0. So instead of 1 to 256, you have 0 to 255. Okay, so which one is better? So in this case, you could argue. I mean, in this case, I don't think there's a clear decision which one is better. You could argue starting from 0 is better because 0 represents none, right? But then the disadvantage is that you got this odd thing, 255, this magic number, right? You got this magic number. On the other hand, if you have 1 to 256, that makes sense. Because why? Because you have a total of 256 values. Why 256? That's because you have 8 bits, 2 to the 8th power. So it's kind of makes sense. But however, when you use 1, it's not, you know, it just means the minimal. It doesn't mean no representation. So anyway, that's a, you know, that's debatable. So anyway, that's it for today, I guess. I'm not exactly drunk, but okay, today is just random chat. Who else is watching? 3 people? Oh, actually, I got 10 people. So am I making sense? We talked about number representation. We talked about mostly why C sucks, the hack mentality, You know, that's what it's, you know, the thing about C is that, let me talk about C, okay? You see, C language and Unix. So I recognize, we have talked about, right? They are practical, which is it's essential, okay? It's essential 40 years ago, 50 years ago. You know, you just need binary. You just need hexo. You are not going to like, oh, let's be general and create a number-based notation. Number 9, any base can work. That's not practical. You do that, your product go nowhere because, you know, remember 40, 50 years ago, nobody, you know, you have very limited number of memory, you know, you are not going to like, that's why Lisp long ago is very slow, and Emacs known for, you know, Emacs is known for 8 megabytes and constantly swapping. So I got a poem here, you know, 8 megabytes and constantly swapping. If you look it up, that's like a phrase describing Emacs 40 years ago. Like, what the fuck? No, you know, if you use Emacs, your computers become super slow. Yeah, but today is like 8 gigabytes, you know, 1 million times more memory. You know, it doesn't matter anymore. So, but 40 years ago, so you are constrained by memory. So there is some point, there is some, at least some point, the way C is designed that way, okay? But the thing, the thing with C is that it brainwashes people, like even today, like what I described before. You ask people about a general idea about number base or this Wolfram design, for example. Where is it? You know, this for example, this is the number in a base 17 notation. This is a number in base 9 notation. You can have any base, any, okay? You talk, when you talk about these things to the general industrial programmers, they're gonna flame you, okay? This C brainwashed fuckhead. They were just going to say, oh, you don't need, you never need it. They are going to go into a denial all the way. That is what C has done. Okay, 40 years ago, it made sense to have just hexadecimal or whatever. But not today, right? You know, so, but C has brainwashed people, the industrial programmers, to such a massive degree. This is just one example, you know, this is just one of the example of number notation. You know, there's so many other, you know, issues. Okay, that's it. Todd Fisher says, well, Kasai has inspired me to add generic bases for numbers literals in my toy programming language. Okay, fantastic. Okay, so kind of understand your argument about 1 versus 0. Okay. Okay, so that's it. I guess that's it for today. I believe that the icon language supports general basis. Icon is a successor of Snowball. Okay, yeah, I don't know about the icon language and Snowball. Like 20 years ago, in the 90s, it was somewhat known, icon. But I guess it just died. Okay, so what? Why is this shit? You cannot click it. Okay, I think that's it for today. 7 people. What? 12 people. Okay, no more people. Okay, pay me. You like my stuff? Pay me. Okay. My drink is gone. Should I get more? I think so. Why not? It's already 1 hour. So any more questions? Today is random. Any more questions? I was going to show you some of the what we're gonna talk about. So we talked about the Emacs poem, 8 megabytes and constantly swapping. We talked about the syntax for color, you know, the 3 hexadecimal 2 digits. Hack, you know, it offends me, offensive. This because like today you program, if you are a programmer, right? It's complexity everywhere, and when you see things like everything, why is it that way? Why is it that way? Well, that's because history, one bag of history. Fuck, So this Unix, the C, this hexadecimal. That's one of the things I despise since like 20 years ago. Why? Because why do I know? How come I know this? Well, because I came from Wolfram language in 1990s. Before I touched any C or Perl or industrial programming or networking or whatever Unix, I came from mathematics. So when for the first 10 years when I'm programming, first 5, I'm seeing this kind of design. Let's see, let's go to color. Okay, so for example, I'm seeing this. Okay, makes sense. Then I started to get into Unix, right? Then I started to learn, hexadecimal. Then then 0x means hexadecimal, but you cannot represent in base 9, but only base 16. Then you have the fuck. That's how I felt. Okay. So if you grew up like people say, if you grew up with a religion, that religion is how you see the world. So if you grew up with the industrial programmers, C, Python, JavaScript, this is natural to you. This is natural. And when I show you this, you say, what? Oh, that's neat. But by tomorrow you forgot all about it. You are back to this fuck. They brainwash your brain. This C, I hate C. Okay, that's today's topic. Why I hate C? Not because it's low level. Okay, because many of the design is just brainless. Do you customize layers for your keyboard, or do you use what is the? Do you use out of the box? Of course, I customize. I always have, whenever you have like, let's go to keyboard. Okay, so if you have a programmable keyboard, especially non-standard, like weird design, you typically always customize it. For example, I did Glove 80. So wait, can you see it? My screen? Yeah, okay. You can see my screen. Yeah, of course. So you can actually see my customization. So let's go back to go here, connection, Glove 80 keyboard layout. There it is. So I show you the standard layout. Then you have how do you customize layout. A little bit complex. That's one of the disadvantage of Glove 80. When you want to change layout, slightly complex. Then you have soft-like key layout. That's my personal layout for Glove 80. Okay, so just lots of articles on my website you can search. So there's a question: is there a low-level language you like instead of C? I don't really know. Okay, so I like Golang very much. Golang is like, in my opinion, the replacement of C. A little bit, because the C type of people, C and C++ and Rust, they insist that you must have control with the memory. Like you must diddle with the the whatever memory. I don't So, but to me, you shouldn't have to do that. So Golang is a language I like very much. Extremely simpler. Golang is simpler than Python, than JavaScript. Okay, and simpler to learn. Very highly documented. I have a Golang tutorial, of course, and I have an article why I love Golang. You can read that. So very simple and very good. But however, you see, I'm not a low-level programmer, so it just so happens, and I don't, I'm pretty old. I don't have time to study it. I like to study more math and logic and proof theory, those kind of thing, and machine learning. I'm not really interested in low-level stuff, so I don't really know any, I never studied assembly language or machine language. So in those areas, I don't know much about them. But so the question is, so I cannot really have experience. I don't have experience to know is there a low-level language I love. So yeah, there's Rust, Zig, Nim. Yeah, so some of the people on our forum like them. Okay. I don't know about Rust. All I know is that there's a lot of know-nothing fandoms for Rust. But I suppose Rust is better than C, simply because it's just like 30 years new language. Typically, newer languages are better. But I don't like the Rust fad, of course. Okay, that's it for today, I guess. Is there anything else, or should I quit? Or should I get some more drink? I think I'm gonna quit. Okay, let's quit in 3 minutes. Let me get a drink. Okay, can you see what are you seeing? Let me get a drink, and in 5 minutes we stop. This shirt is not so good because it makes my tummy pop out. But so I have to. Ten people watching. So what else? Red wine. George, you missed red wine. 100 ml red wine. Okay, so there's an interesting comment. Amphithes says, in assembly language, they only load in memory as bytes. So RGB is 3 bytes only, 1 red, 1 green, 1 blue. Yeah, that makes sense. But still, that's a thing about C. When you talk to the C programmers, that's what they say. When you, for example, what we talked about today, about the idiocy of the RGB, the representation, the hexadecimal, and so that. The C fanatics, especially the smart one, those who have written compilers, they'll say, Xi is a fucking idiot. He doesn't know that, each of these characters is represented as a byte. That's what they say. But these people are the extreme idiots, okay? There's a difference between implementation and design of the language. Just like HTML, this is HTML. This is what you write, and this is what you see. And so notation, there's a difference in notation, then there's a difference in implementation, there's a difference in what machine your language is designed for, and also what kind of task your programming language is designed for. Okay, so there are these issues, right? So the fact that on a specific type of computer, that is digital electronic computer made by integrated chips, CPU, in this hardware, you happens to have these bytes and electronics, Anyway, so that's kind of the implementation issue. Why? Because, for example, we talked about before, this RGB color with the range from 0 to 1. If you design your language this way, does that mean if you say 0.74, it's gonna beep error? Oh, 0.74 is not a byte. Does that mean that? No, of course not. That's your job to implement this, to translate this on the current machine, the current hardware, the state of the art, how many digits, how many bytes represent the number, how large, that's the thing. So your language does not change. Like the C, for example, one of the idiocy this C cost is that you have int, okay? So you have the type int, then you have the type double, then you have the type long. After 10 years, after 20 years, you have to change your type to double or long. The fucking fuck. Java, C, C++, those kind of thing. Okay, that's it. Thank you, guys. So there's a question about Advantage 360. That's the last question I answer, and that's it for today. Pay me, guys, okay? If you like my stuff, you can go to my, Xadi code, xadi.info. So you can PayPal me, and Amazon gift card me, or you can Patreon me. Oh, you cannot see it. Fuck. Okay, so back to xadi.info. You can Patreon me, Amazon gift card, PayPal me, or you can go buy my, buy my emacs tutorial. Okay, fantastic, comprehensive, the best tutorial on the web. Or you can buy my JavaScript tutorial. In the past days, I did a lot of JavaScript. It kind of update my JavaScript website. So anyway, so you have all these functions, the best, the most efficient possible, written by me, the most correct, efficient, and clean code. Okay, then any of those, the fucking famous JavaScript coders with their library on npm. Okay, I'm telling you. Okay, so one of the best is test object equality. Okay, there's quite a few libraries out there that does this, but my code is best. Okay, that's it, and shut down. Okay, so let me go to something I want to say about today. Let's see. Okay, so let's see. Yeah, so Stephen Wolfram is going to be in San Francisco. Stephen Wolfram is going to be in San Francisco, giving a talk at TED AI 2023, October 17th and 18th. So he's going to be there. I'm probably going to go and meet him. Okay, so he's giving a talk at, so that's one of the event, and that's on my Twitter, by the way. Did I miss any questions? So let's see. Any interesting things. Octal number starting with 0 and hexa 06 is not consistent. Okay. Thank you, Oliver Winsphere. Okay, so there's a lot of things going on today in politics, of course. Huge. That's very sad. Huge. We are witnessing, I don't want to say the word, but we are witnessing lots of killings. The American empire is like, yeah. Okay, bye guys.